sustained another barrage.
Why did the most impregnable fortresses of antiquity fall before the Roman legions? Sometimes even before the assault began. The secret lay not only in the discipline of the soldiers, but in the mechanisms that turned engineering into an art form. The Romans approached sieges not as chaotic attacks, but as methodical engineering tests, where each wall had its own key. They did not simply fight, they built, calculated, and crushed, using machines that became legendary. These engines of war were the pinnacle of ancient technology, true mechanical monsters born to overcome stone. Watch the video to the end to learn how the Romans created these machines and what single engineering principle allowed them to crush any wall. I will reveal the most closely guarded secret of the Roman army. This secret is not a specific weapon, but the very doctrine that underpinned their military successes. For the Romans, war was first and foremost a science and an engineering endeavor, and only secondarily an act of bravery. They understood what many of their opponents did not realize. Any wall, even the strongest, is ultimately just a physical obstacle that can be calculated and overcome. It was this methodical, almost scientific approach to siege warfare that was their main advantage. The Roman legion was not just a combat unit, but also a mobile construction company capable of performing engineering miracles. Each legion had its own corps of engineers and craftsmen, known as fabri. These specialists were valued no less than experienced centurions, as they were responsible for building bridges, constructing camps, and, of course, creating siege engines. Their presence meant that the legion could adapt to any situation and solve any logistical problem. In his treatise on military affairs, the military theorist Vegetius paid great attention to training and engineering. He emphasized that victory was achieved not so much by bravery in battle as by careful planning and technical superiority. The Romans preferred to win before the battle even began, using their superiority in logistics and construction. The siege engine was the material embodiment of this philosophy, a symbol that intelligence and calculation surpassed brute force. For the Romans, a siege was not a chaotic assault, but a sequential process divided into clear stages. First, engineers conducted reconnaissance, studying the walls, terrain, and weak points in the enemy's defenses. Then the construction phase began. Siege towers, battering rams, and catapults were built from local materials, primarily wood. This process could take weeks or even months, but it was as inevitable as the changing of the seasons. The psychological aspect played a crucial role. The very sight of the methodical and organized work of the Roman engineers had a depressing effect on those under siege. They watched as a whole forest of siege towers and machines grew outside their walls. It was a clear demonstration that the Romans were in no hurry, that they had a plan and resources, and that they would not retreat until they achieved their goal. This approach was unique for its time. Many barbarian tribes and even civilized peoples relied on the bravery of their warriors and the surprise of their attacks. The Romans, on the other hand, countered this with cold calculation and a systematic approach. They did not try to take a fortress by storm if it was not advantageous. Instead, they surrounded it, built their machines, and methodically destroyed the defenses, saving the lives of their legionaries. The Roman army did not simply conquer territories. It literally built itself into them. The famous Roman roads, bridges, and aqueducts are a direct result of this same engineering doctrine. The legionnaires who built siege engines in peacetime built the infrastructure that connected the empire. War and construction were two sides of the same coin for them, two manifestations of Roman order. Thus, no wall in the ancient world could be considered truly impregnable to the Roman army. Any fortification was only a matter of time and resources. Roman engineers viewed a fortress as a complex task that needed to be broken down into simple components. And for each of these components, they had their own tool in their arsenal, from ballistas to battering rams. Engineers in the Roman army had a special status. They were highly skilled specialists, often knowledgeable in mathematics, physics, and architecture. They supervised construction, calculated ballista and catapult trajectories, searched for water sources, and planned fortifications. Their work was no less important than the tactical decisions of a commander on the battlefield. This philosophy of total engineering meant that the Romans could wage war in any conditions. Whether in the dense forests of Germany, the deserts of Parthia, or the rocky fortresses of Judea, the legions brought their order and their technology with them. They did not adapt to the landscape. They changed the landscape to suit themselves, building ramps, tunnels, and siege ramparts. We would be very interested to hear your opinion. What do you think was more important for Roman victories? The discipline of the legionaries or the genius of the engineers? Write about it in the comments and be sure to subscribe to the channel so you don't miss our new investigations. Are you ready to learn the truth about an ancient sniper weapon that could hit targets hundreds of meters away? The Roman ballista was just such a machine. Contrary to popular belief, it was not a catapult, but essentially a giant two-armed crossbow that worked on a completely different principle. Its main task was not brute force, but incredible accuracy for its time. The ballista was a surgical instrument in the arsenal of Roman engineers. The secret of the ballista's power lay in its torsion mechanism. Unlike a simple bow, which stores energy by bending wood, the ballista used twisting energy. Its arms were not flexible. They were rigid levers inserted into two vertical bundles of tightly twisted ropes. These ropes, or springs, were made from specially treated animal sinews or horsehair. The process was complex and required precise calculation. To load the ballista, two soldiers used a winch to pull the bowstring back. This movement caused the shoulders to rotate, twisting the torsion springs even tighter. At this point, enormous potential energy was stored in the mechanism. The more the springs were twisted, the more powerful the shot would be. When the bowstring was pulled back to its limit, it was locked in place by a complex trigger mechanism. This mechanism was one of the most high-tech elements of the machine. It consisted of a system of bronze levers and hooks that allowed the bowstring to be released smoothly and safely at the right moment. The gunner aimed using special sights and released the accumulated power with a single movement of his hand. The ballista's projectiles were either heavy, feathered bolts similar to spears or round stone balls. The bolts were designed to kill enemy troops on the walls and disable enemy throwing machines. Stone balls, although smaller in caliber than those used in catapults, could cause serious damage to wooden fortifications and towers. The main role of ballistae on the battlefield was counter-battery and sniper warfare. The Romans installed these machines in fortified positions or on siege towers. From there, they could methodically take out defenders on the walls, preventing them from firing accurately at the attacking troops. A precise shot from a ballista could neutralize an enemy commander or destroy a throwing machine, creating a breach in the defenses. The Romans did not invent the ballista from scratch. They borrowed the basic idea from the Greeks. However, it was Roman engineers who perfected the design. They standardized the components, improved the materials, and developed different calibers of the machine. There were both huge stationary ballistas and lighter field versions that could be transported with the legion. Over time, the design became increasingly sophisticated. The late Roman ballista was the pinnacle of this evolution. It was more compact and made extensive use of metal in its construction, which made it stronger and more reliable. These machines were so effective that they remained in service long after the fall of the Western Roman Empire. The accuracy of the ballista required a high level of skill from its operators. They were not just soldiers, but true artillerymen of antiquity. They had to be able to calculate trajectories, take wind corrections into account, and quickly operate complex mechanisms. Training in such calculations took a long time, and these specialists were highly valued in the legion. Thus, the ballista was not a weapon of brute force, but of precise calculation. It allowed the Romans to dominate the battlefield, imposing their will on the enemy from a distance. It was the ideal tool for the first stage of a siege, suppressing defenses and preparing a foothold for an assault. What do you think was the main advantage of the ballista? Range or accuracy? But if the ballista was a scalpel, in the next chapter, we will talk about a sledgehammer designed to destroy walls. What I am about to show you was Rome's real secret weapon. It was not a machine or a blade, but what made them possible: logistics. You can have a blueprint for the most sophisticated ballista, but it is useless if you do not have the resources to build it. The Roman army was a brilliant logistical machine, capable of creating complex siege engines from virtually nothing anywhere in the known world. Siege engines were never transported fully assembled. A battering ram or siege tower was too cumbersome. Instead, the legions carried engineers, tools, and most importantly, knowledge. Upon arriving at the site of a siege, the Fabri immediately set about assessing local resources. The first and foremost resource was wood. Lots of strong, high-quality wood. To build even a single siege tower or several catapults, it was necessary to cut down an entire grove. Legionnaires temporarily put down their swords and picked up axes and saws. They became lumberjacks, harvesting wood on an industrial scale. It was hard and dangerous work, often carried out under cover to protect themselves from the besieged. Then the wood had to be processed. An entire mobile workshop sprang up on site. The wood was dried and sawn into beams and planks of the required size. This required sawmills, carpentry tools, and a huge number of man-hours. Each element of the future machine was created according to standardized drawings that the engineers knew by heart. Metal was no less important. Iron and bronze were needed to fasten wooden structures and create axles, wheels, and tips. Mobile forges always followed the legion. Blacksmiths reforged old parts, repaired tools, and created new metal components necessary for construction. Coal for the forges was also harvested on site. A special supply item was materials for torsion springs. Animal sinews and horsehair were strategic resources. They were needed in large quantities and had to be of the highest quality. This material was often procured in advance and carried along in the baggage train, as it was practically impossible to find it in sufficient quantities at the siege site. The construction process was strictly organized. Different cohorts and sentries were assigned different tasks. Some cut down trees, others carried logs, others worked in workshops, and still others guarded the perimeter. It was a giant anthill, working according to a single plan. Julius Caesar, in his Commentaries on the Gallic War, describes in detail how his army erected the most complex fortifications and machines in a matter of days. This ability to build quickly and efficiently on site was one of Rome's main strengths. Opponents hiding behind walls could only watch in horror as siege towers and catapult batteries sprang up before their eyes like mushrooms after rain. This was another element of psychological warfare, a demonstration of the inevitability of Roman power. In addition to the main materials, many auxiliary materials were required. To protect wooden machines from fire, they were covered with raw animal skins, which were also harvested on site. Ropes, leather straps, and lubricant for axles were needed. This complex supply system worked like clockwork, providing engineers with everything they needed. Thus, the real miracle was not the siege engine itself, but the process of its creation. It was a triumph of organization, discipline, and standardization. Each legionnaire was not just a warrior, but also a builder, capable of contributing to the overall engineering task. This system made the Roman army an invincible force. If you appreciate the same methodical preparation as the Romans, please like this video and be sure to subscribe to our channel so you don't miss new videos with stories about the history of ancient Rome. Guess how long it took to create a machine capable of throwing stones weighing as much as a man? If the ballista was a precision scalpel, then the onager was a heavy sledgehammer. This machine, often referred to as a catapult, was a single-shouldered torsion weapon. It got its nickname Wild Ass, onager, from the powerful, kicking clang that the frame made when fired. Unlike the two-armed ballista, the onager had a single massive throwing lever. This lever was inserted into a single, but very large horizontal bundle of twisted ropes or cables secured in a sturdy wooden frame. This torsion beam was the heart of the machine, its engine. It ran across the entire width of the frame, and the lower end of the lever was inserted into it. The charging process was laborious. Soldiers used a winch or gate to slowly lower the throwing lever down to an almost horizontal position. This movement twisted the torsion spring to its limit, accumulating a tremendous amount of energy in it. The lower the lever was lowered, the more force was required, and the more powerful the shot would be. At the end of the lever was either a bowl or a special sling into which the projectile was placed. As a rule, it was a large, roughly hewn stone weighing tens of kilograms. Sometimes catapults could throw other projectiles, such as pots with a combustible mixture, to cause fires in a besieged city. But the main task was to break through the walls by force. When the lever was lowered and locked in place and the projectile was loaded, the machine was ready to fire. The crew moved to a safe distance and the gunner activated the trigger mechanism. The lever shot upward with incredible force. Its movement was stopped by a cross-beam covered with padding to soften the impact. This sudden stop created the characteristic thudding sound. At the moment of the lever's sudden stop, the projectile at its end continued its movement by inertia. It flew along a high trajectory, crashing into enemy fortifications from above. The onager was not particularly accurate, but it did not need to be. Its task was not to hit a specific soldier, but to methodically destroy a section of wall or tower. The force of the impact was enormous. A stone weighing 30 or 50 kilograms, falling from a great height, could pierce a wooden roof, destroy a parapet, or eventually make a breach in the masonry. Several onagers concentrating their fire on one section could turn a wall into a pile of rubble in a matter of days. It was also a powerful psychological weapon. The constant roar of shots, the whistling of flying stones, and the crash of their fall kept the besieged in constant tension. They could not feel safe even behind the thickest walls. Each impact of the onager was a reminder that their protection was not eternal. The Romans used onagers and batteries, setting them up at a safe distance from the walls, out of reach of enemy archers. These machines required a solid and level foundation, as the recoil when fired was very strong. Often, special wooden platforms or even earthen embankments were built for them. Like other Roman machines, onagers were standardized. There were different calibers designed to throw projectiles of different weights. Engineers were able to accurately calculate the power of the torsion spring and the length of the lever to achieve the required range and power. What do you think was more frightening for the besieged, the accuracy of the ballista or the power of the onager? In the next chapter, you will learn about a machine that did not throw stones but knocked on the gates themselves. The battering ram, or Ares in Latin, is perhaps the oldest siege engine, but it was the Romans who transformed it from a simple log into a complex and deadly mechanism. The Assyrians used the ram in its most primitive form, but Roman engineering brought the idea to logical perfection. The Roman ram was not just a tool, but an entire mobile fortress designed for one purpose: to break through walls. Early battering rams, which were carried by soldiers, were ineffective against stone walls. The Romans quickly realized that mass and inertia were needed to increase the force of the impact. The first step toward this was suspension. They began to suspend a huge log on chains or ropes inside a sturdy wooden frame. This simple innovation radically changed the situation. Now soldiers did not have to hold the log aloft, and they could swing it with much greater amplitude. The next logical step was to protect the soldiers who operated the battering ram. This led to the Testudo arietaria, or battering ram turtle. It was essentially a sturdy, heavy mobile shed that completely enclosed both the log and its crew. The structure was mounted on sturdy wheels, allowing it to be slowly rolled right up to a wall or gate. The protection of this turtle was thought out to the smallest detail. The roof was sloped so that stones and other projectiles thrown from the walls would roll off it. The entire structure was covered with several layers of boards and topped with raw hides, seaweed, or even clay. This made the battering ram virtually invulnerable to fire, which was the main means of fighting wooden machines. The heart of the machine was the log itself. The strongest and heaviest tree trunk that could be found was chosen for it, often tens of meters long. The more massive the log, the greater the destructive force of its impact. The tip of the battering ram was shackled with iron or bronze, often giving it the shape of a ram's head, hence the Latin name Ares. Inside the protective shed, there was a crew of several dozen legionnaires. They worked in shifts, swinging the suspended log. Their task was to get into a rhythm and deliver methodical, powerful blows to the same point on the wall or gate. Although the force of a single blow might not have been as great as that of a catapult projectile, its advantage was its inevitability and consistency. The battering ram worked on the principle of accumulating material fatigue. Thousands of rhythmic blows to one point gradually loosened the masonry or broke the wooden beams of the gate. First cracks appeared, then individual stones began to fall out, and eventually a breach large enough for an assault formed in the wall. Controlling such a battering ram required coordination and endurance. Inside the turtle, it was cramped, stuffy, and very noisy. The soldiers worked in an extremely stressful environment, hearing the blows of stones shaking the roof and the cries of the defenders. But they were well protected, which allowed them to continue their work hour after hour. Roman engineers built battering rams of different sizes depending on the task. There were giant machines that required more than 100 people to operate. For example, the historian Josephus describes a battering ram used during the siege of Jerusalem, which was monstrous in size and terrified the defenders. The battering ram was a weapon for close combat. It could not be used from a distance. It had to be brought right up close to the wall. It was the riskiest and most direct path to victory. It was a symbol of Roman persistence. If a wall could not be bypassed or climbed over, the Romans simply broke through it. Are you ready for the shocking truth about the mobile skyscrapers of antiquity? The Roman siege tower, or turret, was just such a skyscraper. It was the largest, most complex, and most impressive siege weapon in the legion's arsenal. Its appearance at the city walls meant that the siege had entered its decisive phase. The main task of the siege tower was to solve the main problem of the assault: height. It allowed the Romans not to climb ladders under a hail of arrows, but to rise to the same level as the defenders of the walls, and even tower above them. It was not just a machine, but a multi-story mobile fortress that carried assault troops and catapults. The construction of the tower was a colossal engineering project. It was assembled on site from a huge amount of wood. At the base of the tower was a massive platform on sturdy wheels. A multi-tiered frame was erected on this platform, which could reach a height of 20, 30, and even 40 meters, so as to be higher than the most impregnable walls. Each floor of the tower had its own purpose. The lower floors often housed a heavy battering ram that could break through the base of the wall while the battle raged above. The middle floors were filled with legionnaires ready to storm the walls, as well as supplies of water and firefighting materials. Light throwing machines such as scorpions or manubalists were installed on the upper platforms to fire at the defenders. The most important part of the tower was its upper tier. It was equipped with a special drawbridge, or exostra. When the tower was rolled up close to the wall, this bridge was lowered with a crash, forming a passage directly to the enemy fortifications. Across this bridge, the assault squad, covered by shields, could break through the wall and capture a foothold. Like a battering ram, the siege tower was carefully protected from fire. Its front and side walls were covered with boards and covered with wet skins, bags of seaweed, or a layer of clay. Inside the tower, there were always special teams with supplies of water and vinegar for immediate firefighting. Losing such a machine because of one lucky shot would be an unforgivable mistake. Moving this giant was a separate and extremely difficult task. Hundreds of soldiers and slaves pushed and pulled the tower using a system of levers and pulleys hidden inside its base. In order for the tower to approach the wall, the ground in front of it had to be perfectly level. Legionnaires filled in ditches and built special embankments, or onageres, which served as a road for the tower. Sometimes the construction of such an embankment was no less difficult than the construction of the tower itself. The most famous example is the Siege of Masada, where the Romans built a giant ramp to drag a single tower with a battering ram to the fortress. The process took months, but it demonstrates Roman methodicalness and perseverance. The psychological effect of the slowly approaching tower was enormous. It was like an impending earthquake. The defenders saw an entire building full of soldiers, spewing arrows and stones, moving towards them. This undermined morale and made many doubt the strength of their walls. The siege tower was the quintessence of Roman siege warfare. It combined the functions of a battering ram, a catapult, and an assault ladder. It was an expensive weapon, difficult to build and use, but its effectiveness was undeniable. Which task do you think was more difficult, building the tower or bringing it up to the wall? In the next chapter, we will learn about the younger brothers of towers and battering rams. Although towers and catapults were the most spectacular siege engines, the success of an assault often depended on smaller, but no less important devices. Roman engineers had a whole toolbox for every situation. These structures allowed legionnaires to safely approach walls, carry out sapper work, and methodically dismantle enemy fortifications. One of the most common tools was the vinea, or grapevine. It was a lightweight but sturdy mobile gallery. In essence, it was a long rectangular canopy on 4 or 6 wheels. Its roof was made of planks and woven shields, and its sides were often covered with woven mats or skins. The main purpose of the vinea was to provide a safe corridor for soldiers. Legionnaires could push it from the inside, slowly advancing toward the wall while being protected from arrows, javelins, and stones. Several vineas placed close together formed a long protected passageway through which assault groups or workers could reach the base of the fortifications. Vinea were used for a variety of tasks. Under their cover, legionnaires could fill in a defensive moat that prevented heavy machinery from being brought in. They could also use vineas as cover to start digging or to work with siege tools that were too small for a large tortoise. A heavier and more durable version of the vinea was the musculus, or mouse. This structure was lower, stronger, and much better protected. It was not intended for rapid advancement, but for long and dangerous work close to the wall. The main task of the mouse was to cover the sappers who began to dig under the wall. The musculus had a very sturdy triangular roof capable of withstanding heavy falling stones. Its front part was sloped so that shells would roll off it. Under the cover of this armored canopy, sappers could work for hours with picks and shovels, trying to either bring down the wall or make a passage through it. Another specialized tool was the falx muralis, or wall sickle. It was nothing more than a long, sturdy log with a large iron hook at the end. This hook resembled a sickle or beak, hence the name. It was also used under the cover of a vinea or musculus. The task of the sickle was to literally dismantle the wall stone by stone. Soldiers would insert the log into the gaps between the stones or hook it onto the edge of the parapet. Then, using the log as a lever, they would break or loosen the stones one by one. It was slow and painstaking work, but it was effective against walls built with poor quality mortar or dry stone. These seemingly simple devices demonstrate the Romans' attention to detail. They understood that it was not always possible to solve a problem with a single giant tower. Sometimes a more subtle and methodical approach was required. Vineae, musculi, and sickles were the tools of this approach, allowing legionaries to work safely and effectively. This toolkit showed that a Roman siege was not just an assault, but a process similar to dismantling. Engineers found a weak spot and then, using the right tool, methodically dismantled the enemy's defenses. This required patience, discipline, and a large number of different tools. Sometimes Roman legionaries did not need complex wooden structures to approach the walls. In some situations, they themselves became a living, breathing siege engine. We are talking about the famous Testudo, or tortoise, formation. This unique tactical formation was the pinnacle of Roman discipline and coordination, turning an infantry unit into an armored monolith. The tortoise was not just a formation, but a whole philosophy of collective defense. Its formation required incredible discipline and long hours of training. The soldiers in the unit had to move as a single organism. The first row of legionnaires closed their large rectangular shields, scutums, forming a vertical wall. The next rows behind them raised their shields above their heads. They held them horizontally, edge to edge, creating a solid roof over the entire unit. The side rows also covered the flanks, holding their shields outwards. The result was an armored box protected from attacks from almost all sides, especially from above. The main task of the turtle was to safely advance towards enemy fortifications under fire. This formation was virtually invulnerable to light projectiles such as arrows, darts, and stones. They simply bounced off the solid armor of the shields without causing any harm to the legionnaires. This allowed the squad to get close to the gate or the base of the wall. The testudo was the perfect way to cover the sappers who had to set fire to the gate, or the assault team carrying short ladders. Moving under the protection of the testudo, soldiers could do their job without being distracted by constant fire from above. It was a slow but very reliable means of delivering infantry to their target. Discipline was the key to success. Each soldier had to know his place exactly and hold his shield in the correct position, preventing gaps from forming. Their steps had to be synchronized so that the formation would not fall apart while moving. This required not only the strength to hold a shield above one's head, but also complete trust in one's comrades. Of course, the turtle had its vulnerabilities. It was slow and unwieldy, making it vulnerable to sudden counterattacks from the flanks. In addition, it could not protect against very heavy objects, such as logs or large stones, which defenders could throw from the walls. Such a blow could break through the roof of shields. Despite these shortcomings, the Testudo was a formidable weapon in siege warfare. It allowed the Romans to neutralize the defenders' main advantage, their height and ability to fire on the attackers with impunity. The turtle was yet another example of how the Romans turned tactics and discipline into an engineering solution. In essence, the Testudo was an organic version of the Vinia or musculus. Instead of building a wooden canopy, the Romans created it from their own bodies and equipment. This required soldiers of a special disposition, not just brave fighters, but disciplined and well-trained professionals. This formation also had a strong psychological impact. The defenders desperately threw their arrows and javelins, but they bounced helplessly off the slowly but inexorably creeping armored box. It was the living embodiment of Roman inevitability, proving that even without sophisticated machines, the legion would find a way to reach its enemies. Roman siege engines never operated in a vacuum. Their true power lay not in individual catapults or towers, but in their synergy. A successful Roman siege was like the workings of a complex clockwork mechanism or a symphony, where each instrument had its own clearly defined part. The commander-engineer acted as the conductor of this mechanical orchestra. It all began with complete isolation. The first thing the legions did was to erect a circumvallation line, a continuous wall of fortifications around the besieged city. This wall served two purposes. First, it cut off the city from any supplies and reinforcements, condemning it to starvation. Second, it served as a base for the Romans themselves, protecting them from sorties. Sometimes, as in the famous case of the siege of Alesia under Caesar, the Romans built two walls. The inner wall, circumvallation, faced the city, and the outer wall, contravallation, faced outward to protect against any army coming to the city's aid. This turned the Romans from besiegers into the besieged, but they were inside their own perfectly designed fortress. Once the city was securely blockaded, the engineers began their analysis and preparations. They identified the weakest sections of the wall. Then the construction phase began. Under cover from light siege engines and archers, the legionaries began to build embankments, construct venae, and assemble heavy engines, towers, battering rams, and onagers. On the day of the assault, all these elements were set in motion simultaneously. It was a carefully coordinated attack aimed at overwhelming the enemy's defenses. The defenders simply could not be in several places at once and did not know where to concentrate their forces. For example, the assault could begin with a massive barrage. Batteries of ballistas and onagers began methodically firing at the walls. The ballistas took out the defenders, preventing them from raising their heads. The onagers struck the towers and battlements, causing destruction and sowing panic among the defenders. Under cover of this fire, assault groups began to move towards the walls. Some detachments advanced in turtles, carrying ladders. Others pushed venae to fill the moat or begin work with a wall sickle. At the same time, a heavy turtle with a battering ram was rolled up to the gate or a pre-selected weak section of the wall. The assault culminated in the appearance of siege towers. These giants slowly crept toward the wall, firing from their upper tiers and drawing most of the attention. Their task was either to land troops on the wall or simply to create maximum pressure on one of the flanks. The goal of this comprehensive approach was to create several unsolvable problems for the besieged at the same time. They had to choose whether to extinguish the fire from incendiary shells, repel the attack of the turtle at the gate, or try to stop the giant tower that was about to lower its bridge onto the wall. This was the genius of the Roman siege. It was not just brute force, but precise calculation, logistics, and perfect coordination. Every machine from the small vinea to the huge tower was part of a single plan. The Romans did not simply storm the walls, they methodically dismantled the enemy's entire defense system. The fall of the Western Roman Empire in the 5th century AD was a disaster not only for politics but also for technology. With the collapse of the centralized state and its legions, sophisticated knowledge of military engineering was largely lost. Complex torsion machines such as ballistas and onagers required knowledge that was no longer passed on. In the early Middle Ages, the art of siege warfare in Europe regressed. Sieges became simpler again, often reduced to passive blockades or primitive assaults with ladders. The production and maintenance of complex torsion machines required resources and engineers that the leaders of the barbarian kingdoms simply did not have. The battering ram and siege tower, of course, survived, but in simpler forms. The irony is that the next revolution in siege warfare, which occurred in the High Middle Ages, was not linked to the revival of Roman technology, but to a new invention. We are talking about the trebuchet. Unlike the onager, which worked on the principle of torsion, the trebuchet was a gravitational machine that used the principle of counterweight. It proved to be more powerful and easier to maintain than torsion weapons. However, the Roman legacy did not disappear without a trace. First, it was preserved in the Byzantine Empire, which was a direct continuation of Rome. The Byzantines continued to use and improve throwing machines, including the famous Greek fire. Second, knowledge was preserved in texts. Roman military treatises, primarily Vegetius's on military affairs, were carefully copied and stored in monastery libraries. During the Renaissance, when interest in antiquity was reawakened, these texts were rediscovered. Renaissance engineers such as Leonardo da Vinci studied Roman machines, trying to recreate them and understand how they worked. Although the machines themselves could no longer compete with the newly invented cannons, the Romans' approach to warfare remained relevant. The philosophy of methodical siege warfare, the importance of logistics, engineering calculations, and sapper work were all reinterpreted and formed the basis of European military science in the modern era. The true legacy of Roman siege engines is not the machines themselves, but the idea. The idea that war is first and foremost a science, that engineering, mathematics, and logistics are no less important than bravery and tactics. The Romans were the first to apply this systematic approach on such a scale and with such efficiency. They proved that there are no impregnable walls, only incorrectly set engineering tasks. Battering rams, ballistas, and towers were merely tools for solving this task. They were the material embodiment of Roman order, discipline, and an unyielding will to win. When we look at modern engineering troops today, at how they build bridges, clear minefields, and provide logistics, we see a direct continuation of the traditions established by the legionary builders. The advent of gunpowder made wooden machines obsolete, but it did not negate the main Roman discovery. An army with technological and engineering superiority will always have a decisive advantage. Roman siege engines are not just museum exhibits. They are a monument to human genius put to the service of war. They show how far an organized and methodical mind can go in its quest to overcome any obstacle. And this is their main lesson, which remains relevant to this day. We can see that Roman siege engines were not just wood and metal, but the embodiment of an entire military doctrine. They were a triumph of engineering, logistics, and psychology, allowing the legions to crush the most impregnable bastions. Each ballista, battering ram, and tower was the result of centuries of experience that turned warfare into a science. The Romans did not simply storm their enemies. They methodically and inexorably dismantled their defenses, proving that no walls could withstand the power of reason and a systematic approach. What other aspects of Roman history or engineering achievements would you like us to cover in future videos? Perhaps you are interested in Roman medicine, the construction of aqueducts, or the organization of their famous roads? Suggest topics you would like to see in the comments. And don't forget to subscribe so you don't miss our next episodes.